Good morning, everyone. We'll just wait for everyone to jump on here right now. All right, we will get started right now. Good morning. Welcome, everyone, to the 2025 DME webinar series. My name is Mark Zaborny. I am the marketing manager here at DME. Just want to invite you here. And each month, what we do here is we bring industry partners to showcase all of our solutions that could help you advance your operations. Today, we are going to be joined with Brian Wolf, the CEO of FreshStart Purging Systems, who will present Striving for Perfection, Improve Financial Performance with the Implementation of Successful Purge Program. Before we jump into the webinar, a few quick notes. If you have any questions for Brian or for the DME team, please enter them through the chat and we'll address them at a Q&A segment at the end of the presentation. Everyone who registered for this webinar will receive a recording along with some other marketing material, usually with about a week or so after the webinar. So look forward to that in your emails. If you haven't already, please connect with us on our LinkedIn channel and our YouTube channel. I will put the links in the chat as well if you haven't joined us. And also look for any of our future webinars that we have over at dme.net/webinar. Next month, our webinar partner is going to be Slide Products, so we're working on that presentation now, and more details about registration will be coming soon. So with all of that housekeeping, please join me in welcoming Brian from FreshStart. Brian, the floor is yours.
Good morning. Welcome everyone. Hey, Mark, thank you very much for the introduction, and I want to thank DME for this opportunity. And let's get on to it and get a little bit of an understanding of why purging is important and why you should consider it. So let me walk you through what our beliefs are and what we've seen in the industry. Okay, what's the objective of this presentation? Okay, we want to discuss and review why purging is key to your operation. Okay, we want to help you understand the financial gain through good purging processes, and we also want to show you the unique value proposition that we offer. So why do you really want to embrace the purging process, a purging program as in total? Well, there are 6 key items or metrics that we've identified that are important, that we believe that has a tremendous impact on your company. Everything from lean manufacturing to quality improvement, employee development, business growth, and increased returns and sustainability. So how does this all work? So by looking at the key metrics, you're looking at improving quality from of your product, of your finished product. You're looking at the speed of changeover from color to color, or color to material, or material to material. You want to look at decreasing the scrap rates, the contamination, anything that's going to make a product you can't sell, removing that from the equation. You're going to look at lowering your overall production costs, reducing your machine downtime, improving your profitability, and boosting your overall capacity, which means increasing your sales. How do you go about doing this, and how do you assess, whether you have a system that's going to work for you or not? And to do that, really, you just need to understand your process. Then, establish a rubric, some form of format that you can assess a dollar value, so you can actually monitor and set up a cost structure towards that. Then turn around and measure your baseline. What are you doing right now? How does that fit into the rubric, and what does that overall cost look like? Then look at evaluating an alternative system, comparing the two, and then determining what is the best value proposition for you as a company, and how can you use that to increase your bottom line. So we're going to go into the 8 steps here that we've looked at in the value proposition process as we look at it. First one we want to do is we want to say, understanding your process, okay? We think that's critical for you to do, to take a look at and understand where you're going and how your system operates. So you're going to look at the application, the products, processing temperature, the resins, the pigments, the additives, the production costs, quality costs, machine. You're going to look at the size of the mold. All those play into this equation of trying to understand your total process. Then how does that fit into a metrics? Well, here on the left-hand side, we've got an example of an ROI checklist that we've created, okay? What does it do for you and how does it work? We're going to go through that as we go through this presentation and show you the different formats and how you can make this work and how you can actually determine at the end of the day the efficiency of using a good purging compound, okay? You're going to look at things such as scrap rates. How much labor are you throwing at this to make this product effective, or making the current incumbent system work more effective? How much time are you gaining or losing on your equipment? Is there an opportunity that's being lost? Okay, what is the overall cost? Putting all those things together and understanding, is this the most effective use of my equipment at this time, and am I getting the most value from it? So we're going to talk about selection of grade. This is getting into the products that we offer, okay? We've got 4 of them. The most versatile and the largest product that we move out there is MC2HH. It is a product that we're able to put into numerous applications and something that probably we would start you off on, okay? The other ones are very more specific into the actual application and dealing with things as blown film or caps and closures. But if you're using everything else, this MC2HH is going to be our focus product to work with. Analyzing cost factors. So right now, you know, we've heard, hey, I've got an in-house product. It's cheaper than anything you can offer us. It's got no cost to me. I can turn it around, I can recycle it, I can do whatever I want with it, but it doesn't cost me anything. Question we put forth to you, and we ask you to challenge yourself and say, is that a good use of my equipment and my resin compared to what a commercial purging compound can offer? Okay, I think if you evaluate yourself and you're honest in it, I think you'd be a little bit surprised at some of the things that you'll see that pop out of that very quickly. This is an example of one that we've looked at. We looked at, okay, this is looking at purging compound where you're going versus a current process, okay, or an incumbent process. And this shows you some of the metrics of how we would compare it out. So you're going to be looking at what's the scrap, cost of your scrap here. What's the cost of your purge that you're going to be doing? What's the difference of the downtime? Contribution margin. Okay, that's an opportunity that's been lost because you've lost 30 minutes of production that you could be using, making something else with it. What does that all add up? So this gives you an idea of what that finished checklist would look like and what you could possibly see as an up or down associated with total cost of using a purge. Well, this is a very interesting thing. You know, we've done so much improvements, you know, that if you talk to all the major die manufacturers and you talk to Mold Master and others, they've done numerous improvements of their manifolds and being able to help create and make more efficient systems and optimize the speeds and make things more efficiently. However, we're still stuck with a whole pile of challenges out there. We've got challenges coming from resin. We've got challenges coming from pigments. We've got challenges coming from all kinds of other additives that are beyond everyone's concern, everyone's control, and they're moving. They're not stagnant. We're not able to use them in a mold consistently and to be able to say, hey, this is going to work this way all the time. One of the biggest challenges we're seeing is, as in some applications like toys and that, is we're saying we can't use heavy metals anymore as our pigments. So now we've got to go over to organics. Well, the challenge we got with organics is they're not heat stable. So that's going to create a whole problem with our quality. So how do we deal with that? How do we move forward with that? Then we've got zero waste legislation impacting us. Okay, whether it be up in New Jersey, be in California, whether it be on the West Coast, those are coming at us and we will have to work with them. Okay, and while we're dealing with them, we're going to have some struggles, and those struggles are going to be dealt, we'll have to figure out how to deal with. So these are the things that are coming at us where we believe purging compounds have been effective and will continue to grow to address these issues. So here are the most critical segments. We're going to look at the injection molding machine right now. The barrel wall, okay, and that's that distance between the flight and the barrel itself, is one area where we'll see resin build up. We're going to see it on the back end of the flights, okay, where areas that we don't see a lot of additional pressure. Okay, we're going to see it also in the check ring. Okay, the check ring, as we know, it's all sacrificial, and we're going to get grooves and everything else in that. So in those grooves, we're going to have buildup of plastic in that, and then we've got our nozzle. These are all areas that are going to affect the need or the length of time it's going to take to move from one product to the next. So we talk about the path of least resistance, okay? And here we're dealing with the shear stress that goes on a polymer, and we'll get into some of the engineering principles, and I'll talk to you a little bit about that in a second. But what happens is we end up with material ending up against the wall between the wall of the barrel and the flights of the screw. And this is an area where we end up with that material becoming stagnant. Okay, it doesn't move as quickly as we want. We've got temperatures on the outside, and we'll end up with that particular material, for lack of a better word, burning, okay, or oxidizing. And when that happens, it starts to adhere, okay, to the barrel itself. The biggest challenge we have is it ends up releasing at the most inappropriate moment, and you end up with unique colors coming out in your product. You'll end up with splay showing up that you didn't expect, all kinds of other issues that are quality related, then take you down and have you questioning what you need to do to maintain the quality of the product that you're selling to your customer. All these things we've been talking to really come down to about 3 or 4 key properties in engineering and fluid dynamics. Bernoulli's principle is one of the key ones that we look at, as well as the Reynolds number, okay? And between the two of them, we try to balance them to be able to generate the best product for your needs. When we talk about Reynolds number, it's very important, okay? The key with Reynolds number is, and when we formulate our products, is to create the most amount of turbulence in an area of very, very low flow, okay? And that's the most critical thing that you need to be able to achieve. So you need to have a very high Reynolds number, and then that will give you the ability to then polish into those nooks and crannies and effectively remove the contamination. It works well on polishing the surface of the barrel. It works in the back side of the screw. It works quite well in the hot manifolds or manifolds in general. And it's just very good and effective in areas of low flow. Now, here's another thing that we do. We all are very good at this. We understand that as we increase the temperature, we can reduce the viscosity and we can be more effective in filling our tools. That's great. However, when we go to turn around and we look at removing them, we get into some challenges. So first, on the left-hand side, we're looking at the effect of going from resin to resin, okay? And as we go there, we can see that every resin at the temperature which we would process it at has a different viscosity. So when we want to push one resin behind another resin, it's very difficult because you don't have compatible viscosities, and as such, you're going to have one material running over top of another. So this is, this is one of the challenges you have on going resin to resin push. On the right-hand side, what you're showing here is you're showing the effect of temperature on viscosity and shear rate. So you can say if you drop the temperature on the resin by 20 degrees Celsius, you turn around and you can actually increase the shear rate, and you can also increase the viscosity, thus allowing you to be able to push some of the garbage out that you're trying to move. So that's showing a little bit of the dynamics between resin to resin and same resin and dealing with the temperature itself. What does this mean overall? Okay. So here I'm looking at a situation where I've got a changeover and how it's going to be very costly for me. And I'm trying virgin resin to virgin resin. I'm not adjusting the temperature. I don't have the viscosities, in the range that I can push one product out versus another. And it's going to cost me, okay? Every changeover I do, it's going to be about $218. Well, you think, well, that's not too bad. Then I'm looking at one changeover, okay, over per day, over 5 days a week, and I'm looking at that for 48 weeks a year. So that's going to cost me $52,000 towards my bottom line. That's money that I have basically given up because I can do something else with that time. And I can probably sell a product that I can make a lot more money with. So those are the type of things we look at and say, what is the opportunity lost that I can gain to increase my bottom line? We turn around and we put purging compound to it. And this is actual, the numbers on the, this is putting numbers to numbers, okay, in one particular customer. And there's a savings, okay? The customer was able to change over going from color to color in 1/3 of an hour. He's looking at significantly lower downtime on his equipment. He's got more opportunity to do a lot of things. He has less scrap. What I'm not looking at here, and this is kind of really interesting, is I'm not looking at that other hour and 2/3 that could be making something else altogether. But I'm still saving money. At the end of the year, with a purge, there's $38,000 more in the coffers. Now that's not, this is just dealing with one change. It could be just one machine, okay? You could have 15 machines, but you're looking at changing maybe 2 or 3 of them a day. And that number goes on, and it can be multiplied multiple times out. Preventative purging, I should say. Well, here, people will say, well, I'm running the same product and I don't need to purge during the middle of it. I'm going to run it for 2 or 3 weeks. Why am I even considering this? Well, this comes into understanding quality, okay? The quality of the product you're making and keeping an eye on the overall surface issues that you may have, okay? Just dealing from what we were talking about earlier, a pigment that is starting to burn in the equipment, or you've introduced to it some recycled, or you're regrinding the sprues and you're putting them back into the mix. All those things can cause some challenges in creating areas where you will see some black specks being introduced, some color streaking maybe there, whatever. these are some of the challenges that you see within the process itself as you run it for an extended period of time. At that time, basically, what you need to do is you need to monitor that through your quality department, keep an eye on that, and then as you start seeing this start to manifest itself, then start considering doing a quick purge, okay? Not talking about doing a radical, but just turning around and dropping in some purging compound, run it through, and get back into production. In this particular application, customer kept on running. He ran for 2 hours longer than he should have. He created 2 hours of scrap, and versus he could have turned around and just dropped the purge directly in to the mix, shot the material through the manifold, and come out basically, at a cost of about $50. So, he's looking at a savings of around $240 per. So what does that mean overall? You've gained time, you've reduced scrap, you've increased your return on working capital. And someone will say, well, what does that mean? It means that I'm making money on every piece I'm selling. I've reduced the power consumption per good part. So the more good parts I move, I'm not shooting extra, I'm not spending more time on operating my equipment and producing bad parts. So I'm making more good parts per overall power consumed in the plant. Same thing with overhead. I'm also, because I'm being better at using the power consumption and overhead and all the other things, I'm becoming more sustainable and I'm reducing my carbon footprint. These are all good metrics to be able to sell to your stockholders and also to your customers and things of that nature, to say I'm being responsible and I'm being sustainable. It doesn't have to be anything other than more than I'm doing it ahead, I'm working ahead of the game versus trying to play catch up. Shutdown and sealing. Well, we all like to go on holidays, and we're looking for times down, whether it be during the summer, whether it be at Thanksgiving, whether it be over Christmas, whatever. We need to give our employees a break. So what do we do at that time? So we turn around and we want to shut down our equipment. We want to do it in a way that when we start it back up, we're running it in the fastest manner. We're not dealing with all kinds of black contamination. We're not dealing with all kinds of startup issues. By using a proper sealing purge, you're actually reducing the possibility of oxidation of the material that we talked about earlier that's along the wall of the extruder, okay, whereby air can get in, and you're taking the heat, so they're going to be slowly coming down and slowly going back up again. They're going to turn around and oxidize and burn some of that material. If you have it as a complete filled with resin, that not resin, but a purge compound that is actually heat stabilized, okay, then you're turning around and you're going to mitigate that occurrence, and you have a much better product coming out. That will help you dramatically be up in manufacturing much faster and be able to take more opportunity to produce more product as soon as possible. Well, went a little bit further than I needed to. Here's what you're using it for, okay? Basically restricts the airflow into the injection molding, basically into that area between the screw and the barrel, as I talked about earlier. Okay, reduces the degradation and and generation of the contaminants, and it's going to give you faster uptime. So what have we set up to this time? Okay, we're going to say that with a purging compound, you have the opportunity to increase production, reduce scrap, reduce rejected parts. You're going to obtain faster resin changes, color changes. You're going to be faster mold changes, You're going to increase your profitability, your revenue through production, and increase your profitability. I think those are all good things that I like to see if I'm running my business. So we go back to what we talked about earlier, and this is a recap. Basically, the biggest thing you're going to save on is time, and with time comes money. So that's the key. So you have opportunity costs also that to take into consideration here that gives you the ability to manufacture more material faster and more effectively for your customer. So I'm going to give you, I got 5 case studies, or actually things that we've actually done in the market out there, and just want to give you an overview to it. This first one we ran at Moldmaster. We did an evaluation by using a third party that basically we trusted to do an impartial assessment for us. What they did is they looked at we worked with a 16 cavity tool for a cap, and we're running a hot manifold, or runner manifold. And what we were looking at was, one, looking at a resin to resin push to see how effective that was. Then the second one we wanted to do is we wanted to take a look at our material versus 2 of the market leaders of purges in the industry. Okay, and we want to evaluate that and see what that all came out as. One of the things I want to point out here, this is all the conditions we ran under, is the gate size. Okay, and the reason we wanted to look at the gate size is because we did all molding through the tool, and we actually molded parts with the caps, with the purge into the caps. After we ran it purge to purge, okay, we used up just a little bit over 5.5 kilos of material of running straight resin push to push, and we were not 100% satisfied with the product. Okay, at that time we stopped, and we decided that we're going to move on at that time. That cost to us in that process was at $12. Okay, when we did the looking at the FreshStart versus the 2 competitors, we used the same amount of material in each application. We did the same number of purge shots, and then we went right into introducing the actual resin, and then seeing how effectively we'd be on making a product that was acceptable. Okay, so in doing so, after 2 minutes of purging, we then turned around, introduced the resin, and after 7 shots with the FreshStart, we were on color. We were basically clean, and then with the other 2, we were anywhere between 30 and 90 shots before we were actually considered to have a clean product. Okay, the overall cost structure in this format ended up being basically 50 cents for 42 cents for us, and then $1.87 and $5 and change for the other one. So the summary that came out of Moldmaster was basically that we presented the most effective cost savings, okay, of all 3, and including the push-to-push application. This was another interesting one. We had a customer that was doing dark colors. They were using fluorescent pigments. The customer was having challenges in going from a dark color to a white pearlescence. And what they were doing is that they were actually pulling the screw and barrel, and they were turning around and cleaning it. Okay, extended amount of material was lost. They would make over a gaylord full of product when they were finished, of just scrap that they would turn around and they would sell out because they weren't able to use it themselves. In this application, we were working with a 96 cavity hot disc hot runner system from Moldmaster, and the cycle time was basically 7.3 seconds, and the shot was 157 grams. What we did is we molded the part right through the hot disc application. We ran the trial, and very quickly we were able to get everything up and running. Within 45 minutes, we'd finished the purge. We introduced the white color, and then after another 30 minutes, we were now right on what was considered acceptable by the customer, and we moved forward. So overall, in this application, we generated less than 4,000% less scrap. We're in and out of it just in the color change more effectively. And we gave the customer 10 hours of additional production time that they never had before. This was a very unique one. It was a sequential gate hot runner system. It was a 5-pound truck bed panel. It was for automotive. They were as lean manufacturing. They were going from dark colors to basically black to beige, and they were doing multiple color changes because they were working off the automotive production schedule. So it said, hey, today you need to make 10 of these and 5 of those. Then that's all they made, and then the next day they'd be making exactly what the requirement was for the automotive production. They didn't have the opportunity to do any long runs, so as such, they were doing multiple color changes. We're running basically. Here's the outline of the format that we were running, and here's the results. So what we did is we ran 25 pounds of purge through the barrel. Then we purged through the mold another 20 pounds for a total of 45 pounds. Okay, and we've got a cost in there of $3.35. The competitor, okay, was using 75 pounds at a cost of $2.10, and the other competitor was in there was using 100 pounds at $3.15. At the end, even considering the difference in the cost, unit cost of the purge, we were still very competitive. However, the most important thing in the equation was how many units or how many parts the customer had to make before they considered to be acceptable. After the 4th shot, on the 5th one, they were turning around and they were putting that into the box and shipping it off to the OEM. So that was the big impact that we had on this application. So the amount of resin that was scrapped was nominal, relatively speaking to the others, and it has a huge impact on the customer's ability to do more production with the amount of equipment that they had. So if comparing ourselves to competitor A, then competitor B, there was a huge substantial change in the equation. You're looking at downtime, a fraction of an hour, okay, versus the ability to look at close to an hour or an hour and a third. That's huge time in the automotive business, particularly when you're looking at how to increase your profitability. This gave them the opportunity to do a lot more with less. It would put more money on their bottom line. This was a toy block application. Okay, it was a 62 cavity. They were using liquid pigments. Cycle time was 13 seconds, and the shot was 32. The pictures you saw earlier, about the way it coats out on the screw and on the nozzle and on the check ring. Yeah, this is very common seen with liquid colors. Liquid colors have a tendency with pigments, with resin to just coat out every square inch that you can, particular areas where you have scratches and things of that nature. However, that being said, the customer was pulling their screw historically in this application, and we asked them just to turn around and take our product and drop it directly into their injection molding machine and shoot it right straight through their mold, and we followed it through. By the fourth sample we took, which was 12 minutes into the equation, okay, we were starting to see the last bit of the purge get out of relieving. By 14 minutes, we saw no sign of the purge left. By 15 minutes, the customer was satisfied that there was no color bleed over at all. And at 20 minutes, they were back into production with the next 7 colors. And you know, up to this time, they were looking anywhere between 4 to 10 hours, depending upon whether they were how close the colors were, or whether they can turn around and pull a screw as quickly as possible and clean it out. But this gave them the opportunity to have a huge change in their operation. So we're looking at a 450% efficiency over the incumbent. Okay, and they were looking at basically $125 increase in profitability just by using the purge. Now, this is not including the opportunity cost that they had, so that they were able to make more with less. At this particular time, they were looking at the potential of buying 2 more injection molding machines, and they found that with this change, they did not need to move forward with that acquisition. Last one we have here is another one. You're looking at a dark color going to a lighter color. Okay, the customer again is pulling the screw. They're again minimum of 8 hours of downtime. And here's what they started off. We started off with a on the left-hand side, I should say, we have the original product being shot. Then you see the color as it molds out. You can see the tan color. That's our purging compound reacting and taking that product out. And then you see translating into at 7 minutes or 17 minutes processing. We're now into a clear, and then at that point, the samples went off to QC, where they turned around and they did 9 minutes of their work on it, and a total of 56 minutes from beginning to end for them. And they were turned around and said, yeah, I'm interested in looking a little bit further with this. So here we're looking at just on the purge for them, it was over a $2,000 savings on moving from one product to the from basically pulling the screw versus turning around and looking at a purge in the application, as well as just the sheer time. Sometimes they're pulling the screw or doing a resin to resin push 12 to 24 hours. It was all over the map, and they figured out, yes, by using a purging compound, they were able to see significant savings. And what we did here is we helped them by writing an SOP to help them internally with their operations, so that they could take it onto different product platforms. And we're constantly working with them to develop other applications, other SOPs for other applications for them. So why do we think we stand out? Is it that we purge through injection molding machines more efficiently. We also purge through the runner and the manifold together. We can reduce the total amount of scrap, okay, and we can help overall increase your profitability and increase the opportunity for you to do more with less on your equipment. Thank you very much.
Awesome. Thank you, Brian, for this presentation. If anybody on the call, if you guys have any questions, please put them in the chat and we will get to them right now. Questions could be for Brian, DME team, anyone right here. First questions that we do have, Brian, is I'm always using black color in my process. Why should I consider using a purge compound?
That's a very good question. Thank you for bringing that up. Black by nature, okay, is as an oil that's burnt. So you've got it's a hydrocarbon that will turn around and it will stick to the wall and in the flights and out of your screw quite quickly. And then problem is as it keeps on building up, it gets a little bit harder and harder, and you'll end up with granulars being released. And they will turn around and mar your surface. So you'll have surface imperfections. That's one of the biggest things associated with it. And it's just good nature to have all your equipment always clean all the time too. So that you're able to if you were to drop in clean resin to make a part, you can have that opportunity.
Okay, great. All right, next question we have here is, can you explain the shutdown and sealing process? And what are the benefits for weekend or holiday shutdowns?
Give me a second here. Let's go back up here for a second. There we are. Okay. So what happens here is you take your current material that you have, you basically let it exit the machine altogether, and then you come follow right in behind and you seal up the total barrel with a purging compound, okay, with a sealing compound, and then you basically turn around and make sure that you have enough, just sort of fills the top portion of the neck a little bit in this area here. The reason behind it is that air gets in, and with the material that's already coating the barrel of your extruder, and also on the screws in that area, it's going to turn around and it's going to seal that up so that air can't get in there and oxidize that. If it oxidizes it under the heat that you have on the system, it will turn around and basically burn it. And at that particular time, when you start the material back up, start making it, you've purged out your sealing compound, and you put in your next product, you're going to see black specks, and you can see quality issues that are going to continue for some time afterwards. So basically, using a sealing compound is of value to try to mitigate the loss of time, startup, following an extended shutdown period.
Okay, and how long is that shutdown? I mean, how long does that last for a shutdown? It's like for a week, 2 weeks, a month, or?
Well, once you basically load the material in there, okay, you can turn your heats down, okay. Ideally, if you can turn them off, that'd be the best thing. Then you want someone to come in the evening before the shift starts and turn your temperatures back on, so that when you come in first thing in the morning, you're able to get back up. So if you came in at midnight and had someone turn on the heats on your line, so that things would be ready for you to start up at a 7 o'clock shift, then you would be more than adequate. In the sealing compound would be heat stable enough to be able to allow you to facilitate that.
Great. Okay, again, guys, if you have questions, please put them in the chat. One question we got here is, how will this purge work with Macrolon 2558 clear medical grade piece? So how does purge work?
Oh, good old polycarbonate. That's one that everyone has a challenge with. Our purges work quite well with polycarbonate. That was one of the first things we got involved with many years ago, was people having challenges molding polycarbonate. Yes, polycarbonate has a tendency to char very quickly if there's any hang up in the system, and our purging compound works quite efficiently in being able to remove the oxidized polycarbonate in the equation.
Great. And can FreshStart products be used with liquid colorants?
Oh, there's another good question. Yeah, liquid colorants are amazingly well in being able to develop a color in pigment. And at the same time, they're extremely interesting how they coat out a barrel and screw and check ring in your nozzle. And particularly if you've got little wear issues on your nozzle and your check rings. Yes, we've been very good in being able to do that. The key to making that one effective is our proprietary and patented technology that we've developed around the Reynolds number, into being able to lower it while being able to then create the turbulence that gets into those areas of low movement. That's where we differentiate ourselves. But you're right. Generally, liquid colors are challenging, and we welcome the challenge.
Okay. Again, if anybody has questions here, just let us know. Also, if more questions come later on after the webinar, just know your DME representative is available to you. You can send emails back over to us, and we will get back to you as well with an answer on that one. Also, we will be sending out this presentation after, probably about a week after when we're done here, and along with some other marketing collateral on there. And I'm just waiting for a couple more questions to come on in, if there's anybody else. One question we have here is, how long does it typically take to complete a color change?
That's an interesting question, and that's a good one to ask. It all depends upon the size of the injection molding machine and the size of the die and how many cavities you're working with. Okay. In general terms, what you're looking at is how long it takes to, the first part is you're going to use about 1.5 to 2 times the capacity of the barrel to clean out the barrel, the screw, and the check ring and the nozzle. Okay, that's the first thing you want to do. Isolate that section and clean that. Then you're going to move over to do your mold. Okay, it will take then approximately about 1.5 to 2 times the barrel size to do that as well. So you're looking at that overall time will depend upon that, but how long does it take you basically to process that material? And so it could be anywhere between, I would say, 15 to 30 minutes, depending upon the size of the equipment. And then right after that, you're following up with your virgin resin, and within a few shots, you're into your product.
Okay. Next question we have here is, what is the temperature range that the purge compound is effective? And currently changeover between resins of various temps.
Correct. Yeah. Well, yeah, that's one that I always get asked. Okay, so ours is set up to run between 350 and 625 degrees. Now, and that's Fahrenheit. So what do the people say? Well, can I use it for peak or some of the ultra high temperature ones? And there is a special SOP that you can do that, we can work with you to do that. We have done that in the past. We've worked with a number of customers that have, gone everywhere from peak right straight through to polycarbonate to polyolefins, and we ran it with a trial with them over a 1-day period. So it can do over a wide range and a very high temperature range, but there is some, we need to talk with you as a particular customer and walk you through how to do that most effectively as you get into those ultra high temperature products.
Okay, great. All right, last call for questions. Anybody has any on here? And the last question I have here is, which FreshStart grade would be most suitable for hot runner manifold applications?
Well, all of them are set up for hot runner, okay? They're all of them, and even to probably the smallest gate you can see out there. We've proprietarily developed it for that application. The first one, without knowing the particular resin, okay, the most versatile of all of them is the MC2HH. This is the first one that I would recommend with not knowing what particular resins you're looking at. However, if you are needing something very specific, we would have that as a separate conversation.
Okay. And how do you determine the right amount to use?
The rate of the amount used is dependent upon the equipment, the size of the injection molding machine, the size of the shot that goes into the tool. And generally what we look at is 1.5 to 2 times the size of the barrel itself, the capacity of the extruder, and then again, the same amount for the mold itself, the tool, the die.
Okay, and all of that the DME rep can help you out with, along with the good people at FreshStart as well. So, all right, well, that looks like all the questions that came in. I'm gonna kind of pause a little bit, just make sure we get everybody on here. There's one last question. But other than that, again, we'll send all the information over to the attendees on this call, so you could watch and share with your colleagues. And again, Brian, I want to thank you as well for giving us this great presentation on here. So,
well, thanks very much to DME as well. We appreciate the opportunity of working with you.
Thank you. Awesome. Well, that is it. So this will conclude our webinar right now. Thank you, everyone. Again, we will be back next month for the next part of our series, which will be with slide products. So look forward for more information about that in the next few days, and we will see you then. You guys have a great July, and we'll see you soon.